number 15 is really two different problems in one. I redrew the graphs and I wrote out what I saw as the top of the catalyzed line for this one. It was really halfway between 150 and 200, so that's why I estimated it at 175. The rest of these values were a lot easier to read off the chart. For both of them, the first thing I want to find is heat of reaction. Heat of reaction is products minus reactants. On this first graph, on both graphs, the products are wherever the reaction ends. So on this graph, my products are at, oh, I didn't write that one. My products were at 150, so this line went over to 150, is right where this one should end. My products were 150, minus my reactants, the very beginning, were 100, therefore I got a value of 50. For here, heat of reaction, still products minus reactants. My products were 30, my reactants were 100, I get negative 70. The next question is heat of reaction reverse. Now, heat of reaction reverse is still products minus reactants. What the reverse tells me is that instead of these being my reactants and these are my products, I've relabeled them. So it's like I'm approaching the graph from this end, in which case, if I'm starting here and ending there, those are my products, those are my reactants, I get negative 50. For this one, those are now my reactants, those are now my products, I get positive 70. Activation energy is always top minus start. By start, I mean the reactants. So on this one, the top is at 200. The start is at 100. So I get an activation energy of 100. On this one, the top is at 150. The start, the reactants are at 100. So I get a value of 50. Activation energy reverse, let me erase these actually. Activation energy reverse. Reverse doesn't change the formula. It's still top minus start. So the top of this reaction is still 200, but reverse means I'm starting over here instead of over there. So in this one, the number I'm actually plugging in does change. I'm not using 100 anymore. Instead, I'm using 150. For this one, top is still 150, but my start is now 30. So I get 120. Catalyzed activation energy. Still top minus start. We're no longer doing reverse. The top, though, on the catalyzed one is the top of the dotted line instead. So instead of using 200, I'm going to use 175. Since we're not doing reverse, the start is still the very left, 100. For this one, the catalyzed top is 120 from here. The start is 100, so 20. If you look at all the activation energies we've done, they're always positive. We're always putting energy in, therefore a positive absorbing energy. You should never get a negative activation energy. Activation energy, catalyzed, reverse. Activation energy is still top minus start. Catalyzed means I'm using the top that is dotted. Reverse means I'm actually starting over here. Top means I'm using the catalyzed means I'm using the top that's dotted. Reverse means I'm using the start over here. Last one, relative heat of the activated complex. Relative heat of, there's no work to show, it's just pulling a number off the axis. So activated complex is the top point. Relative heat of the activated complex here, 200. Relative heat of the activated complex there, 150. If I said relative heat of the reactants, they'd both be 100. Relative heat of the products, 150 here, 30 there.